Christie is an assistant professor at the Kent State University in Ohio, United States, and she's the head of the Bahlai Lab. She is an applied quantitative ecologist and population scientist and uses approaches from data science to solve problems in conservation, sustainability, and ecosystem management. In her talk today, Christie will discuss the philosophy of reproducible quantitative methods.
Okay, so I'm going to zoom out a bit in this talk, and I'm going to talk a lot about why people don't adopt open practices. Because we've heard a lot already about why we do, and yet we as a scientific society generally aren't reproducible and we aren't open. So we're going to explore a little bit of the why about that. So this is my lab. I chose the most flattering picture of all of us that we could. We're kind of a combination of things in this lab. We study functional ecology, so we look at how communities of organisms do things in the environment. So an example is pollinators. So if you have a whole bunch of different pollinators contributing unequally and responding to the environment in different ways, how do you quantify how much pollination is going on? And so we develop metrics to describe things like that. We also look at populations and time series and look at the internal rules governing how they fluctuate and when they change. So we specifically develop tools to identify changes, sort of edges in a time series. And then finally, we're developing data infrastructures to support citizen science. So how do people see the data they're collecting and how we can use that in scientific discovery down the line. So zooming way out, way out. We are scientists and we are doing some really difficult stuff. We are on the edge of human knowledge with all of our work, right? The whole point of science is to push things forward. And that is by its very nature difficult. So anything we do in science can be pretty hard. And science is also changing. I don't want to disrespect the scientists of the past, but they had low-hanging fruit. You know, Newton said, oh, an apple went down. Wow, that's cool. Guess things are attractive. Cool, we figured that out. But now we have this incredible flood of information that we are navigating. And so my field, applied insect ecology, it used to be you just counted bugs. Now we have remote sensing, we have genetics, and we have all of these layers of data that, frankly, our field was not built to cope with the data influx. And yet, we're still training our students in very simple statistical methods and sort of assuming that things will all come out in the wash. And then this is something that's really interesting because science likes to think of itself as outside of culture, but it's not. It has been really shaped by the culture that it was formed by. And so in the past, we've had technology that shaped how we've approached scientific problems and how we've done science that we still have the legacy of today. And they aren't the science, they aren't the discovery, but they're the cultural elements that shape how we do it. So for example, how do you describe a new species? You go out in the field and you find a new fly, and it's got different traits from all the other flies. How do you get it on the official zoological record? Well, there's a particular set of rules. I actually have it up in another tab if you want to go through. It's a many page document describing how you would go about registering officially this new description of a fly. And it involves printing the description. And there's a rule, and it's changing as of very recently. But up till very recently, in order to officially publish the description of a new species, you had to have published by a recognized scientific journal, and it had to be printed, and it had to be deposited physically in several libraries around the world. And this started to become a debate in the early 2000s. Why are we printing this on paper and putting it in libraries? And you had people kind of coming back and it's like, well, there's an important reason for this. What if the internet collapses? Then no one will know what my fly is. And of course, if the internet collapses, at this point it's so integrated into society that I think we have bigger problems than your fly. But it's something that got entrenched in the rules of how the science was done. And so for a brief period in about 2007, it was okay to also print it on optical discs and deposit it in several libraries over the world. And now it's getting a little bit more recognized that you can do digital publication. But the old guard in the community was very, very resistant to adopting this new technology. Botanists came ahead a little bit quicker. 2011, the botanists accepted that you could have digital publication. But there are actually still domains in zoology that require printed publication. Now, in science, we also have this sort of cowboy myth. It's the lone genius communing with nature that is the one making the discovery. But how many of you work alone? Yeah, a little bit, right? But completely? No. I'm very sorry.
You always have your own work, right?
Well, you have your own work, but it's not done really in that vacuum.
Well, yeah, I'm kind of going.
Yeah. But if you look at sort of the popularization of the scientist, it's that person alone writing at the whiteboard or pouring some colored liquid into a tube and going, I got it. And at least in entomology and applied insect ecology, we're working together. We have, the stuff that we're sort of primarily pushing forward, but it's not a lone battle. And there's also this culture of siloing your work. How many of you have heard of scooping? Okay, so a few of you.
The term of the event.
Yeah, so scooping is the idea that someone takes your idea before you and publishes it and ruins your life as a scientist, basically. And when I was going through graduate school, it wasn't that long ago, I had a senior grad student take me aside and say, okay, well, make sure you're not putting any unpublished work on this poster because someone might scoop you and then you won't be able to publish your work and then you will have to live in your parents' basement for the rest of your life. And so on, just all of those sort of mythologies associated with scientific ruin. If you don't keep it secret, if you don't keep your work secret within the lab group, if you don't keep it siloed, you are putting yourself at risk. Now, there's been studies, of course, done on this, and this is a very, very minimal risk associated with most fields. There are some fields that are a little bit more cutthroat, and there are some high-profile cases, but I don't know if there's so much scooping as people just working faster than others, and that's kind of okay. But yeah, there's this oral tradition, I'd say, that describes scooping, and so it sort of the cautionary tale that keeps you in your silo. And then there's the idea of looking the part. Now, we all have an idea in our head of what a scientist looks like. Am I what a scientist looks like?
Yeah.
Thank you. But when we have this sort of cognitive dissonance about what a scientist is and what we are doing, we have sort of this filter that is applied to the scientific community. And we don't give credibility to people who don't look a certain way in science. We don't give promotions. We don't give the backing. And so we can resolve all these things with open science, right? So we've got this visual metaphor for what science is in its traditional form. Fortress on the hill, one path in, good luck. And so open science comes along, and it is the panacea for all of it. So we're going to fix all this. We're going to bring communities in to open science. We're going to enhance our reproducibility with technology and just better practices. Transparency, we're going to cut down those walls and let people see that it's not just the old white man doing science. We're going to increase our own accountability and efficiency. It's going to be great. The web changes it all, but once again, we have not all adopted open science. So we all are fairly familiar with the open science cycle. This is a nice graphic that's been developed by the Center for Open Science. And so they actually just talk about the open science workflow. I won't go into that too much because I want to go into some other things. But there's all these different steps. And so this is a really ideologically pure idea. And people love ideologically pure ideas. And people, well, the nerds particularly, when nerds are into something, they get really into something. Now, anyone want to identify my costume there? Okay, thank you. And so when nerds like an idea, they really throw themselves into it. And so what we see is a bunch of nerds, all with a slightly different take on open science, throwing all of their effort into different pieces of technology. And that's awesome. We've got all of these different pieces that have been classified as part of the open workflow. So every one of those little icons is someone's blood, sweat, and tears, or a team of people's blood, sweat, and tears. And that's really cool, but there's pushback. If you go to, say, my grad supervisors or my postdoc supervisor, and I said, okay, I've got all these new methods for you to adopt, they're going to just kind of look at me. No. I mean, I can make my students do these things, but I can't make people above me adopt these things. And so the question is why? If we've got a better way to do it, why can't we get them to do that? Well, the first person that you're going to run into who's pushing back is the person who is busy. They simply have so much on their plate that they simply can't take it on anything more. And so I'm a new professor, and I am very bad at email. I didn't realize how bad I could be at email. But there's just so much coming in at all times that it can be just so overwhelming. And I don't even really have that much responsibility because there's a lot of other professors who have a lot of things on their plates that I don't. Like my service load is very minimal right now, so I'm not on many university committees. I only have 4 students now. So, things could be worse. And I'm barely treading water on a lot of these things. And so when you have someone who's very overloaded and you say, learn something new, adopt this, no, you've got a technique that can do it, and you feel like you're comfortable with it, but adopt this new, they're going to just say no. And they're probably going to get a little bit mad at you, even if they aren't, really mad at you, but just for the lack of understanding that they're just barely making it. Then there's folks that I think are probably an extension of the busy. These are the openly hostile towards open science people. These are probably the people who've been pushed just a little bit too hard. And so I'm highlighting a tweet thread that came up a few months ago. So for those in the back, I recently reviewed a manuscript. Another reviewer referred to the fad for the equality of ongoing research in the replication movement. An atmosphere of fear to disagree that has been fermented by accusatory believers, holier-than-thou methods disclosure statements, symbols of ethical purity to intimidate authors, the infamous badges, reviewers who automatically demand, on no grounds, raw data, fear of a team of replication bullies that will descend for speaking against the movement. So advocates like me of the replication studies, full methods disclosure and open data have a long way to go with some senior researchers. So that's an actual response to review, that someone has said in response to the reproducibility movement. So there's some openly hostile people out in the community. And then there's folks that perhaps have a little bit more of a relatable experience, the worried. So we've all seen reports about how data is being used inappropriately, essentially for evil. And Frankly, I don't see the equivalency of me putting out a spreadsheet with how many aphids I saw in different soybean fields to people's personally identifiable information. But some people say open data, that's dangerous. Open data can be used against people, and open data can be used for manipulating people specifically. And it's a little bit of a different thing. It does sideline our movement a little bit, though, because this is something that is on people's minds. It is of concern. And then there's people who just don't feel served by the open science movement. Like, they've made suggestions and they feel ignored. So there's a lot of technological solutions to things that sort of your workaday scientists don't feel are problems. And so it's like, well, why do I need to learn that new technology if I have a simple solution to this problem? The learning curve is too high. One of the things that I hear a lot is like, I don't want to learn to code. And I mean, that's, problematic. But, giving people sort of a gateway to reproducibility that doesn't necessarily involve them learning a new language might be helpful, for instance. There's also, for instance, the open peer review movement, which is great. Like, if everyone could have sort of a public discourse on science and felt comfortable making those critiques, that would be a truly wonderful thing. But think of the junior researchers, the protected minorities, the underrepresented groups. Are they going to feel comfortable criticizing a senior person in their field without repercussions down the line for their careers? And you can say, well, you can see the bad behavior out in front, but I'm going to tell you something else. We all know about the very high profile senior researchers who have been repeatedly accused of sexual harassment and sexual assault in the field, in the various fields of science. And they're publicly being accused. Their bad behavior is publicly documented. And yet careers are still being ruined for junior researchers because, they are just trying to whatever, some sort of excuse to protect that senior researcher. So if we can't protect junior people and minorities and people in at-risk positions in this highly cut and dry way, how can we protect them in peer review? So here we have your visual metaphor for open science. Top of the mountain, but at least there's an octocat on the top. And so, I don't have the same numbers for open science, but it was last year in Wired, someone commissioned a study and they found that the diversity in open source software contribution was actually worse than the diversity in tech, in the general sense. So we have these ideals, but we aren't quantitatively doing better than the society that we are, the better society that we're trying to build. And so I have some recommendations about how we can bring people in and how we can mitigate these filters. So we want to give everyone a place in open science because that's really the goal of open science, isn't it? It's making science more available to more people. And so I have some strategies that I've been personally working on involving specifically addressing the educational deficits and then improving the culture of science through some sneaky ways. You have to do some culture jamming. So every university administrator loves it when you say, I'm going to come in and I'm going to teach your students hard skills. I'm going to teach them to code. I'm going to teach them, structural equation modeling. All the university administrators love the phrase structural equation modeling right now. Just any particular tech buzzword or high-ended statistical technique, you can tell them they're doing this. But in reality, you're not teaching them just the tool. It's not just the tool you're teaching them. You're trying to teach them about the culture of science and how to do it better. So can we rephrase these hard skills for students in terms of soft skills? And what I found is I tend to have better retention of students if I can spin these hard skills into the soft skills. Like, how are we going to use this technique to improve our communication? How are we going to use that technique to improve our replicability, like, and our reproducibility? How can we use this technique to save you time in the long run? And also just peppering it with the why of why we are doing these various technical skills. So like within the context of academic publishing, why do we still have to publish species names on paper? Well, it's like, this is the cultural reason for that. And exactly how we would change that, how we would go about changing that is also the issue there. And so there's a lot of current efforts in this sphere, which is awesome, and it makes me really happy. So I've been personally involved with the Mozilla Science Lab and software carpentry and data carpentry. And I find that those groups really speak to me because I don't have any training in coding other than what I taught myself. I was a newcomer to this. Probably only about 5 years ago, I was a newcomer. And I found the community intensely alienating. And working with these people, it helped bring me in. And so I think that their central missions are actually very helpful to the community. And so through my work with them, what I've done is I've developed a course which offers a controlled immersion. Now, I identified a problem in how we were doing graduate education in North America. And I don't know if this completely applies to the European system. But in biology in North America, typically you get your grad students coming in, they take their required courses. Usually one of them is a biostats course that uses statistical methods that were developed in the 60s. And around that time, they're developing and they're collecting their data, often in the physical space of the field, and not given any information about how to design a spreadsheet so that they could actually use their data down the line. And then they finish all their data collection up about 3 or so years later, and their advisor says, okay, write your thesis, write your dissertation. And there's this huge gap between what they've been taught and what they need to do. It is the equivalent of just dropping someone in the ocean. And it's kind of ridiculous. So I developed the reproducible quantitative methods class, which is open, by the way, if you want to teach it anywhere. It is actually available on my GitHub as a complete lecture note series and activities. But what it is it's sort of a guidebook for taking students through a real data set all the way through the open science workflow. And so we start with somebody else's data that I get permission to use. Usually I go on Twitter and I say, hey, I'm running my course again. Anyone want to partner up and work on a project with my students with some data that you have? So, cast aside data that probably didn't make the high priority list from someone else's thesis or something like that. And what I give you is 6 to 8 grad students working on it for a semester to write it into paper form. Because of course the paper is still the currency of science. So that's a whole motivating factor for the students. And then we work through it. We do a basic analysis. Reproducibly, we use GitHub. We do project management through GitHub. And we work all the way through it, and we write it up as a paper. And so here's the instructor guide, if you ever want to look it up. Also looking up just Bahlai and RQM on Google, you will find it. It's nice having a unique last name for that reason. So in the first offering of the class, we were actually pretty successful. By the end of the semester, we had a working product. We got together a few times a week during the summer to just push it forward, and by the end of the summer, we had a paper to submit. So we submitted a preprint to bioRxiv, and here's where the real success story really begins. Well, it was still on bioRxiv. It was picked up by Science magazine. And so we had a little feature written on it when we had it just in preprint form. And then we eventually published it in Royal Society Open Science. But suddenly the university administrators were paying attention to the open science workflow because, of course, we were delivering products that satisfied the previous paradigm of science while also completing the open science workflow. And I think that that is one of the key things to the sustainability of this. We have to survive in the current scientific paradigm before we can shift the paradigm. Because if we all come in and we completely adopt this new paradigm, we're just plain not going to get jobs. So we have to kind of play the game in order to get through. So how do we change this culture? Like, how do we undermine, how do we jam this culture? I like visual puns, I apologize. Well, we want to create a culture where we disincentivize bad behavior. I'd say that the way we do science right now, we are not doing that. But in open science, we're building it. So we can do things that specifically disincentivize bad behaviors. And when we're creating these open projects, we need to make our expectations clear. We also want to show our humanity. It's really intimidating to come into this world and there's all these wonderful, smart people doing things. And newcomers are not smart at what you're doing. They don't know the culture of the project, and they don't necessarily know, what you've already tried, what all the steps are. And so they're going to make mistakes. They're going to make cultural mistakes, and they're going to make scientific mistakes. And so inviting them in and showing them how they can help is a really important thing to build that. And just simply being kind, especially to the newcomers. Being kind is different from being nice. Being nice is you get a crap contribution to your project and you go, thanks, that's great, and then just kind of filing it away. That's being nice. Being kind is, thank you for contributing. Here's how you can improve your contribution, because it helps them learn and it also helps them feel valued. This is something that I find is really important. We do this in mainstream science and we do this in open science. We romanticize the brilliant jerk. How many times have you heard, yes, so-and-so's a jerk, but he or she has contributed so much to this that we just kind of put up with it? All the women in the room are nodding. One thing I've learned is that we are all fundamentally replaceable. And if someone is affecting the culture of a project in a way that is detrimental to all of the other users, or at least a portion of the other users, they aren't actually helping the project that much. And so we need to hold members of our community accountable for being the difficult person on the project. And so here's where we go into our clear expectations. So I've created a code of conduct for my lab group, and I've made it a general policy whenever we sort of have an open project that we have a code of conduct for that open project. And that way when we have people contributing from the community, we want them to be able to not waste their effort. We want them to be able to contribute effectively, and we want them to not, frankly, screw up the culture of the project. And so if we have clear expectations about how people can contribute to the project, that's a really important first step. The next step is enforcing those things. And that is something that I personally have not figured out. And so if anyone has any conflict management short courses that I can attend, I'd be very happy to join them. Because I still have not figured out how to completely manage a group like that. But having the expectations very clear tends to keep people in line, because then you can just sort of point to the expectations when things start going a little bit awry. This is part of my personal philosophy. But this is something I learned in software carpentry. During software carpentry training, we use a few pedagogical techniques that kind of violate the rules that from any other sort of school of pedagogical techniques. We fail in front of our students. We do live coding. And so students are watching you typo. They're watching your code not work. And that is incredibly powerful and incredibly humanizing. Because, you know, anyone can copy a snippet of code and have it work and not know why. But if you are live coding, you know, just sort of from a general scheme, you are teaching the students debugging in practice, like right as you're going. You're teaching them that you are not infallible. You're teaching them that coding is a process. It is like learning a new language. You're going to make mistakes, and that's okay. And it's sort of giving them permission to try rather than be perfect. And one of the things I've found with taking on students of my own now is that students coming into grad school are very used to being right. And it's really hard for them to make that transition because you're bringing in the best students and they've done very well at an undergraduate education. And so being a grad student is being wrong like all the time. And that's actually a really big part of the learning process. I mean, I'm sure you've all seen the diagram of what science is and what a PhD is, where you have the sphere of human knowledge, and the PhD is that little teeny blip on the side. You are operating at the edge of human knowledge, and everything around your blip is unknown. You're going to mess up. That's cool. I've also found that finding a community that will support you in your project is an absolutely essential thing for getting work done. So this is me and the Mozilla Fellows. And so this was my group that brought me really deeply into the community. Just finding a group of supportive people is so essential in this. And so this community, I'm sure you'll make some friendships here that will help push you through and help you develop your skills. And that's really exciting. So look around, make a buddy system. It's great. And then practicing kindness in science. Giving meaningful and helpful feedback. No one wants to be told they suck. But lots of people are looking to improve themselves. And so if someone is inviting feedback, this is another thing, don't necessarily give feedback unless someone asks for feedback. But yes, giving positive, helpful feedback, constructive feedback is really essential. I know that my first few paper reviews as a grad student, they were mean. I thought that the point of being a critical scientist was criticism rather than feedback, rather than helpful feedback. I mistook being highly critical with being rigorous. And that's not necessarily true. So we can all lift each other up rather than push each other down. And so my goal with these ideas is to go viral. He's not actually sneezing. He's got a spray bottle. I checked the setup of this. But yeah, the idea is we want these ideas to catch on. We want them to go viral. We want people to embrace open science in a more humanitarian way than we've embraced actual, like, mainstream science. Now, I feel like I've gone through this quicker than I usually do. Oh, about right. So I guess I can invite questions now.